Hello everyone. My name is ZhengLi and I'm a PhD from Huazhong University of Science and Technology. Right now, I'm the OpenLooKeng committer of the OpenLooKeng community. Today, my shared topic is the OpenLooKeng heuristic index framework architecture, analysis, and application practice. So here comes for the agenda of my today's talk. First, I will introduce the basic ideas of OpenLooKeng and the OpenLooKeng architecture. And then I will introduce the OpenLooKeng heuristic index framework. And after that, I will introduce how to use the heuristic index from OpenLooKeng and how to create your own index technology with the interfaces provided by the OpenLooKeng heuristic index framework. First, I will introduce the basic ideas of the OpenLooKeng. So if we refer to the big data landscape, we could find that the big data is pretty complex. And this figure shows a typical big data system. As we can see, we have several layers that components and compose the overall big data system. First, we have the physical layer. We can use the ARM server and the x86 server, and we have VMs, we have cloud. And after that, we can build our data storage layer that we can do the data storage such as we're using the common HDFS with different data formats such as text, the ORC file, the Parquet file, or the common data files. And we can also use distributed storage such as FS, HDFS. We can use the object to store, or we can use the file system. And above the data storage, we have the data management layer. Then we can use the data log to control or management the data relationship among different data storage. And we also use the data security to do the data management to provide the high-level data security layer. And above the data management layer, we have the computer engine layer. As we can see, the computer engines in the big data area is pretty complex. That is, we use different engines based on the different scenarios. As for the batch scenario, such as we do some data processing and data generation, right now we usually use the Hive or Spark engines. And if we talk about the stream dealing, we usually use the Flink engine to do the streaming computation. And for the graph engine, we can use the graph base above the HBase to do the graph analysis. And if we refer to the such as log analysis, we will use the elastic search. And above all the computer engine layer, we have the layer of data enable. Then we do the data integration, the data development, the data governance, and the virtual data warehouse. And the user's applications will build on the data enable layer that we can develop all kinds of applications, such as data processing, the prediction of the sales, such as all other things. Besides all the four data components, we have different data sources, such as we have the data from the RDBMS, we have the data from log, we have the data from IoT devices, and we have the data from the website. And all the data will be loaded into the data storage layer and be stored into the data storage and management by the management layer and using by the computer engine. As for we also have the management layers that will provide the several key features such as security, such as tenant, such as configuration, such as performance improvement, and such as tolerance. However, as we can see, we have different computing engines based on different scenarios. So the overall big data architecture will be very complex, and the users have to use different engines based on their application scenarios. So actually, OpenLooKeng, the key idea of OpenLooKeng is to do the fusion analysis, such as we want to build all the computing scenarios above the existing data sources, and all the computation, such as batch or the stream and the point query scenarios are all do the load data or the entrance of the data in via the OpenLooKeng. That is, OpenLooKeng will be the entrance of the data lake, and if we want to do the batch or the stream or other data analysis, we can just use the OpenLooKeng with the single entrance of the whole data lake scenario, and then that we can simplify the overall architecture of the big data landscape. So here comes the OpenLooKeng architecture. Actually, OpenLooKeng is the typical MPP-like architecture that consists of coordinator nodes and worker nodes. User will send their commands such as circle query to the coordinator, and the coordinator will do the parser, analyzer, and do the query execution plan generation. And after that, it will the coordinator will schedule the execution plan to the worker node, and the worker node will do the data processing based on the generated physical plan. That is, maybe load data from the data source and do some aggregation, such as join and all other operators. After that, the worker will return the value to the coordinator, and the coordinator will return the final result to the user, and the user will get the results of their circle queries. As we can see in the figure, actually OpenLooKeng has two typical designs. One is the data source connector, that we can use the data source connector to connect different data sources such as Mexico, such as such as Elasticsearch. And we can also use the data center connector to connect one OpenLooKeng cluster to another OpenLooKeng cluster. And we can do the query across the network domain. So in general, the OpenLooKeng is the MPP-like architecture that with the multiple coordinators to avoid the single coordinator failure problem. And we use the column processing engine to fully occupy the computation potential of the hardware. And we also use the in-memory pipelines to do the data processing to maximize the overall performance of the engine. And then I will introduce the OpenLooKeng heuristic index framework. Referring to the index technology, we will refer to, actually it's very common in the RDBMS. In RDBMS, a database index is a data structure that improves the speed of the data retrieval operations, a database table at the cost of additional writes and storage space to maintain the index data structure. As we can see the figure, actually, in common cases, the index engine is coupled with the storage engine, and the storage engine using the index engine to quickly find out the data and return to the execution engine. In general, the RDMMS is a closed system that the storage engine and the computation engine are tightly decoupled. So the execution engine can fully execute the properties of the storage engine as well as the index technologies to quickly find out the data they want. And we can see different RDBMS and different databases use their own indexing technologies. For example, the index technology of Mexico and PG are quite different. So different technologies or the index technology could not be applied to the different engines because the computer engine and the storage engine are tightly coupled. So if we see the challenges in the big data area, that is a common part that the storage engine and the computer engine are usually decoupled with limited bandwidth, limited network bandwidth for better scalability. Since the computer engine and the storage engine are decoupled, the storage and the computation can be expanded according to the actual needs. So based on these ideas, the index technology faces greater challenges since the data is not controlled by the computer engine. For example, if we use HDFS or have to maintain the data is usually organized as the ORC data file format, for example, or the Parquet data format, and stored on the HDFS. And the index technology or the file format is controlled by the half of the HDFS. So if the computer engine wants to index the file quickly, it is become impossible because the file format could not apply or could not provide the index interfaces we want. So the question is how to design the index in the big data scenario to fully accelerate our query engine performance. So OpenLooKeng proposed heuristic index framework that is the middle layer between the storage engine and the execution engine. Here are several properties of the OpenLooKeng heuristic index technology. The first is that it is agnostic to the underlying data source, and it can be used by any engine. Because all the design of the heuristic index layer is also decoupled with the storage engine and the computation engine. And the second is that the existing data can be indexed without rewriting the existing data files. Because in big data scenario, the big data is amount is huge, and it is become impossible for us to reload the data or change the original data to another data format or to another data warehouse. So if we can do the indexing without rewriting the existing data files, it could help to reduce the overall time, the total time of the creating index time. And also we can create new index types that are not supported by the underlying data sources. For example, in the ORC file format, for example, it only supports the index technology such as Bloom filter. So if we wanted to create other index types that are very important to the query engine, so it become impossible very hard because the file format is not supported the index types. And the final one is that the index data does not occupy the data source storage spaces. We can store the index data in the close to the query engine and hence improve the overall performance. So the key ideas of OpenLooKeng heuristic index that we want to filter out the data in the early stage and reduce the amount of data transmitted over the network and the amount of data involved in the query engine processing, and hence to improve the overall query performance. And here comes the architecture of the OpenLooKeng heuristic index architecture. If we refer to the architecture of the OpenLooKeng, we can see there are several components in the coordinator. When a user sends the query to the OpenLooKeng using the OpenLooKeng client, the parser and analyzer module will do something to deal with the incoming SQL statement and do the such as metadata check and other things. And after that, it will send the query to the planner, and the planner node will generate the initial execution plan for the incoming stage, and then optimize the plan using the existing optimization rules to improve the overall performance. And after that, we use the data scheduler module will schedule the overall work or overall execution plan to the worker nodes, and the worker will do the data processing based on the data stream API and load the data from the underlying data source and do the processing. And after once the data is processed by the worker, it will return the data to the coordinator, and the coordinator will return the result to the user. So comes to the heuristic index technology, we added the middle layer between the data source and the OpenLooKeng cluster. That we provided two kind of heuristic types that can do the data scheduling or do the data filtering in two different stages. One is the task scheduling phase that we wanted to cut the split to reduce the number of tasks scheduled to a worker, and we can also reduce the amount of data to be loaded to the computing memory when we read out the data from the data source. In general, we support multiple index structures such as sparse index, such as Bloom filter and the min-max technology, and we also support some dense index technology such as the Bitmap technology. First, I will introduce the Bloom filter index technology. Such as a Bloom filter, it is a data structure that it can determine whether a value is existed in the existing data. So we can use the Bloom filter to quickly determine whether a value exists in a set. Only the equal sign is supported. So we can determine whether each split, such as the worker load the split into the coordinator, and to see whether each split contains the value to search for and read out on those splits that may contain the value. As a result, most of the splits that does not contain the value will be filtered out early in the coordinator before data scheduling, and the worker won't to load the data from the data source and do the processing and the filtering out in the data, and hence improve the overall performance and reduce the data amount loaded from the network. So here comes the example. If you want to query select star from the test base where the column equals to a value, the data of the underlying data source will cut it into several splits based on the data itself. So if we create the index on the column J1 and the table, so we can, when we schedule the splits on the coordinator, we can based on the index values to see whether the data contains the whether the split contains the value. So if the split does not contain the value we want, we can filter out the split early and won't spill it to the worker. So hence improve the overall performance. And the drawback is that we have to run the create index command to create indexes in advance, and this takes some time to finish. And here comes the B-tree index technology, such as B-tree. It is a data structure that we organize the data in a tree level, and the B-tree contains the data in order. So if we query the B-tree, the indexing performance is much better than the Bloom filter technology. For example, the B-tree contains the mapping table. If we want to choose the column values greater than value, it can be searched by the tree level and returns the value, whether the value is contained by the split or not. So the query complexity is much better than the Bloom filter because the Bloom filter we use is a hash table and it contains such as ON complexity. And another advantage of the B-tree is that it supports additional operators because it can support such as operators such as greater than, less than, and other things, while the Bloom filter can only support the equal condition. As for the Bitmap index, the Bitmap index is a dense index technology that it wants to filter out the rows that do not match the predicate by providing the Bitmap technology for the predicate column. Because in the column-based storage, which records the value of the column, dictionary, and the bitmap, it is applicable to operations that use the dictionary to quickly query. For example, if we want to select star from the table where such as column equals to a value, after the data is read out from the data source, we can use the bitmap to filter out the data line by line. And we can just return to the lines that are actually containing the value and filter out the lines that does not contain the value and reduce the overall data amount that would be sent to the query engine and improve the processing performance. And the drawback is the bitmap index that is also needed to run the create index command to create indexes in advance. And unlike the B-tree and the Bloom filter index technology, it cannot filter out the data before the data scheduling. That is, data is also loaded from the network. Yeah, but we can use the bitmap index to reduce the data amount sent to the query engine. And the final one is the star tree index technology. Actually, star tree is a tree data structure that is storing the pre-aggregated results with the time and the space trade-offs. As we can see in the left figure, the star tree actually stores the pre-aggregated values in the tree node. And if we query if the user wants to query to do the aggregations on the several columns with different aggregation type, we can use the pre-aggregation technology to reduce the latency. because the star tree index we have, it is kind of like the pre-aggregation technology, and we have stored the pre-aggregated values in the tree node. So if the user wanted to query the data to see the aggregation values, we can just refer to the star tree index to find out the final aggregation value rather than load the data from the underlying data source and do the aggregation on the engine. So we can improve the overall query performance, especially the high basic dimensions queries. Okay, finally, I will introduce how to use the heuristic index technology and how to create new index based on the heuristic index framework. If we want to use the Bitmap, Bloom filter, and B-tree and min or max index technologies, we could use the command of the create index. For example, we provide the command of the create index with the index name. Using, you can refer to the heuristic index types such as Bitmap, Bloom filter, B-tree, min or max on the specific table and specific column. We support the where predicate that we can use the where predicate to create index on the select partitions. And also we support the where clause that the where can be used to specify the index properties or index level. For example, for the Bloom filter index technology, we can use bloom.fpp to indicate the error rate of the Bloom filter. And then we can support other heuristic index technologies. You can refer to the individual index document to support properties on our OpenLooKeng website. Unlike the Bloom filter and the B-tree and the min-max heuristics type, the star tree index provides an individual command to create the star tree index. In general, the star tree index is cutting down into 3 stages. The one is creating a star tree cube. We provide a command use the create cube with the cube name on the table, and we can use the with clause to specify the aggregation type such as count with distinct, with average, with max, and we can specify the group columns such as nation key, and we also can specify the star tree index storage file format such as ORC file. And we also can specify the partition key of the storing star tree index to improve the loading performance. Next, we want to add data to the cube. We can execute the command insert into the cube command. For example, we can insert to the cube, insert into the cube the national cube where we can point the. For example, the column national key is greater than 5. After we add the data to the cube, we can use the new cube. We can query the original table using the aggregations that were included in the cube. For example, we have created the count star star tree index using the table nation with the column nation key greater than 5. If the user sends a query that is select count star from the nation where nation key is greater than 5, grouped by the nation key, the original table will be replaced by the star tree index. That is, we won't do data load on the table national key, but we just load the data from the star tree index and then return to the count star value, the aggregations values to the user by using the pre-aggregation star tree index. So finally, there is several commands that we can add new text implementations. Actually, OpenLooKeng heuristic index provides simple interfaces to create user-defined index type. So we cut the user-defined index type to 2 components. One, we have to implement the indexing method, and the other we have to implement the adding and the persisting values. And for the indexing methods, we have to implement two methods. One is the matches, and the other is the lookup. For the matches interface, it returns the true or false based on the expressions input by the user or input by the index caller. For example, if we create an index min-max with the value greater than value, the user input expression is the value greater than a specific value. We can use the expression to return to the index caller that if the index can contain the value or not. So we can use the matches method to quickly pass the index data. And for the other, the lookup is just returns the integrator of the index technologies, and the lookup interface is not necessary. And for the adding and the persisting values, we provide the interfaces add values and deserialize and serialize. We can serialize the value based on the input applications. So here comes the conclusion. So with the decoupled architecture, with storage and computer engine that separated, offering fast and efficient index capability is a huge challenge. In order to solve these problems, we created a third independent index engine, allowing us to retain the flexibility of the original design while retaining the benefits of index engine. So index engine comes with a provide sets of index module, but you can bring your own and extend it to specify it to meet your needs easily. So I think that's all for my theory. I think you can refer to our OpenLooKeng website to see more details about the heuristic index details. Thank you.